Today we will talk about the smart contract, the introduction to smart contract, the application, how to write the Solidity codes, and hacking the industry standards. And I will start with the origins of smart contract. The term smart contract first come over 20 years ago by Nick Szabo, a digital currency and cryptography pioneer. And Nick is famed for designing Bitcode, and which may consider to be the precursor to Bitcoin. The start with the last decade, Nick Szabo created this term with the goal of using distributed ledger to store contracts. These contracts actually came to life with the emergence of Ethereum several years ago. In the contrast with Bitcoins, these cryptocurrencies was focused more on the blockchain and its development rather than the currency itself. So what is the smart contract? Actually, the smart contracts work by the following simple argument. If or when something happened that we are detecting and do the statement. And that statements that are written into code on blockchain, a network of computers executes the actions when the conditions have been met and verified. And these actions could include the releasing funds to appropriate parties, and registering a vehicle, sending a notification, or issuing a ticket. And the blockchain is then updated when the transaction is completed. That means the transactions cannot be changed, and only parties who have been granted permission can see the result. And I have a comparison between the traditional contract and the smart contract. In the traditional contract, if you deal with someone, for example, for buying a car or buying a house, you need to do a lot of paperwork with the banks and government and notaries, and it takes so long time and so much money to execute the contract. But for the smart contract, you just need to write the codes or prepare the smart contract. Then if the time comes, it executes it automatically. I have a chart here there is the comparison between traditional and smart contract. In the traditional contract, it takes 1 to 3 days or more for the prepare the contract and do the action. And it is too expensive because you are doing a lot of paperwork, and all the paperworks are starting with, I think, 1,000 liras today. And you need lawyers to write the contract. But for the smart contract, you don't need any lawyer. Actually, you can be, but it may not be necessary for smart contract. And it makes all the things automatically. So I have two examples for the implementing the smart contract on the industry. One of them is about supply chain management, and the other one is about the insurance. For the supply chain, with the multiple stakeholders and the business transactions, supply chains are inherently complex. So many challenges exist, including the lack of transparency and traceability, and difficulty managing risks and disruption, and the need to build trust and reputation. The blockchain technology ushers in the potential to solve these challenges through use of smart contracts. They reduce complexity in a supply chain through automatic verification and the execution of multiple business transactions involved. So it is too easy to detect all the transactions, all the executions in the smart contracts, the blockchain platform. Decentralized immutable record also ensures all stakeholders have equal access to information and helps build trust. So smart contracts improve the efficiency of the supply chain and allowing to be more agile while powering relationship between among the stakeholders. And for the insurance example, the preparation and the settlement of insurance claim can take months because of lack of automatic administration. And it is troublesome for insurance providers and adds the compliance charge and inefficiency. And smart contracts will automatically streamline the mechanism by automatically initiating the demand when such events occur. And for the insurance, I have an example, real life example, which is the company Dynamis. The Dynamis is a peer-to-peer insurance company built completely on Ethereum blockchain. They focused on unemployment insurance. The policy applicants need only provide their LinkedIn profile to verify current employment status. And for those who are unemployed, the company's blockchain will verify through profile connections and issue insurance payments to these unemployed people. So now I will talk about the DeFi examples. For many cryptocurrencies and the decentralized applications, the apps function using the smart contract code to facilitate the exchange of goods, services, data, funds, and so on. So while users of the centralized financial institutions such as bank or credit unions or the governments are able to rely on intermediaries to manage the transactions. But DApps must use smart contracts to ensure that each transaction is legitimate, transparent, and trusted. For the bank or government, we are trusting on them. But for the decentralized applications, we need to have a trusted mechanism to do the financial functions, and that goods or services must the provisions of the agreement.
The most used language for coding a smart contract is Solidity. It's an object-oriented programming language that is used for implementing smart contracts on blockchain platforms, mainly Ethereum. As it's an object-oriented programming language, its syntax is similar to other object-oriented programming languages as well, such as Java. In this code example, we can see that it's already similar to Java as well, and we can see on the first line the version of Solidity that is used. On the fourth line, the contract's name, and below the name, like we can see the contents of it. Like as it's a simple storage example, it has just two functions. The first function is used for storing the number we want to store, and the retrieve function is getting the number that we just stored. And for this example, like all the functions are public, so everyone can just get into the smart contract and just change the data. They want to use the functions however they want. And but for this example, like we are just changing the owner of the contract. But especially on line 6, to prevent everyone from accessing our variable and our data or functions, we are creating a private address called owner and creating a modifier at line 8 to check if the message sender is the owner. To see this code working on blockchain as well, it's possible to use the Remix Ethereum IDE, which is integrated development environment, which is at the same time, which is an open source tool. I highly suggest it. For hacking the industry, like as you might know, smart contract rules are absolute, and once it's published on the blockchain, like there's no go back. It's always there, and it will be really hard to change it. We need to, like, it's kind of impossible to change it as well. And if there's a loophole, it will be used, and we can see that it's happening. Now I'm going to talk about the most expensive hacks, two of the most expensive hacks, and one hack that forced the Ethereum blockchain to make a hard fork that divided Ethereum, so Ethereum Classic and Ethereum, as two separate blockchains. Like both of them are still alive. The one causing the hard fork was a DAO hack. A user found a loophole through a fallback function and used it to transfer 3.6 million worth of Ether to his account. To this day, there are two sides of the story. Like the one that defended his actions because it's not a hack, but a bug or so-called unintended feature that lets him earn ethers, and the other side that just called this as a hack. Ronin is a sidechain of an NFT-powered play-to-earn game called Axie Infinity, maybe you know them. And hack is done by using hacked private keys, which cost like 552 million worth of cryptocurrency just get stolen. For Pol network hack, a hacker found an exploit using a vulnerability in Pol network's contract calls to get $611 million worth of cryptocurrencies. And Pol network had to make a deal of $500,000 to hacker. And the hacker claimed, after the claiming money, he said that the reason was not about the money, but sending a message to like all of the networks, such as Pol network, that there is always a chance that if you're not careful about your code, if there's any vulnerability, it will definitely get abused to get stolen money. But how can we prevent it? We can prevent it through smart contract audits. A smart contract audit is an extensive methodical examination and analysis of smart contracts in order to prevent any errors or unwanted outcomes as well. In these examinations, they are trying to find the vulnerability of smart contract in order to prevent market manipulations, draining the funds through a loophole, as the examples that I just gave. There are three main vulnerabilities that can be traced or that can be found. Re-entrancy issues, it is one of the three. When a smart contract makes an external call to another external contract, external smart contract, before any effects result, the external contract can then recursively call the original smart contract and interact with it in a ways it shouldn't be able to. As probably the original contract's balance hasn't yet been updated, there's a chance that you can just get access to the amount of money or the amount of coins that you were not able to access. And through this one, the first DAO hack that I just stated happened, as I recall. Through this issue of exploitations of fallback functions are possible. Integer overflows and underflows. When a smart contract carries out an arithmetic operation, but the output exceeds the storage capacity, there's a possibility that this can lead to incorrect amounts being calculated. You can somehow make it a really big integer number, or you can just make your account number zero as well. That's possible. For front-running opportunities, any kind of badly structured code can provide forewarning of market purchases or sales, and this in turn can allow others to use the information and trade on it for their own benefit. It's not a really good example because I cannot remember the details, but some of the free trading companies, they collect your data and they collect your purchase plans before they will give you some kind of latency to make transaction happen, and in that latency they can do the exact same to make your purchase a bit higher or to make a market manipulation. What are the industry standards for smart contracts and for blockchain technology? As its development rate is too quick for industry to keep up with it. For right now, we can say there's a specific standard that all smart contracts have. Well, yes, for Ethereum, there's ERC20 and ERC721, but there are other tokens that are used as well. For scaling the industry, we need common standards to agree on. If there are no common standards, it will be too many extra data to compute and store every time that we are going to use them. That's why we need some sort of data normalization. As right now in the internet, on the internet, there are too many data and there are no specific standards as well. It's the same with smart contracts. It's the same with internet. It's the same with a lot of leading technologies on digital era. In short term, it will be unwanted, but for the long term, it's a necessity as well. There are references that we use to create this slide, create this presentation. Thank you for your time and
Thank you for listening.
us.